most climate models do not yet account for a new discovery done by University of California, Riverside. Methane traps a great deal of heat in Earth's atmosphere, but also creates cooling clouds that offset 30% of the heat. Greenhouse gases like methane create a kind of blanket in the atmosphere, trapping heat from Earth's surface called long-wave energy and preventing it from radiating out into space. This makes the planet hotter. The researcher says a blanket doesn't create heat unless it is electric. You feel warm because the blanket inhibits your body's ability to send its heat into the air. This is the same concept. In addition to absorbing long-wave energy, it turns out methane also absorbs incoming energy from the sun known as short-wave energy. This should warm the planet. But counterintuitively, the short-wave absorption encourages changes in clouds that have a slight cooling effect. This effect is detailed in the journal Nature Geoscience alongside a second finding that the research team did not fully expect. Though methane generally increases the amount of precipitation, accounting for the absorption of short-wave energy suppresses that increase by 60%. Both types of energy, long wave from Earth and short wave from Sun, escape from the atmosphere more than they are absorbed into it. The atmosphere needs compensation for the escaped energy, which it gets from heat created as water vapor condenses into rain, snow, sleet, or hail. Essentially, precipitation acts as a heat source, making sure the atmosphere maintains a balance of energy. Methane changes this equation. By holding on to energy from the sun, methane is introducing heat the atmosphere no longer needs to get from precipitation. Additionally, methane shortwave absorption decreases the amount of solar radiation reaching Earth's surface. This in turn reduces the amount of water that evaporates. Generally, precipitation and evaporation are equal, so a decrease in evaporation leads to a decrease in precipitation. This has implications for understanding in more detail how methane and perhaps other greenhouse gases can impact the climate system. Shortwave absorption softens the overall warming and the rain increasing effects, but does not eradicate them at all. The research team discovered these findings by creating detailed computer models simulating both long-wave and short-wave methane effects. Going forward, they would like to conduct additional experiments to learn how different concentrations of methane would impact the climate. Scientific interest in methane has increased in recent years as levels of emissions have increased. Much comes from industrial sources as well as from agricultural activities and landfills. Methane emissions are also likely to increase as frozen ground underlying the Arctic begins to thaw.